So this lesson will continue where we picked up or where we left off in class, and that's with working with literal equations. Now, remember, a literal equation is nothing more than an equation in which each of the variables represents a known value. So we're used to seeing literal equations, particularly in geometry, because literal equations are what we use to solve for things such as circumference or for area, or even working with one of these formulas in reverse, maybe solving for the base, knowing what the area and the height of a particular rectangle are, for example. So we already were left with the task of recognizing these formulas and identifying what they represent. Now, in some cases, you probably know these formulas and as being familiar enough. And in other cases, you probably have to do a little bit of research, but we will obviously wrap up with making sure we understand what all these formulas are used for. Now, the backside of the notes is where we're going to spend some focus now. These are all literal equations. Some of them, well, I think all of them are probably taken from the front side. All of them, any literal equation is designed to be solved for a specific variable. So if you notice the first equation, A equals BH, we probably recognize that as being familiar enough to us. A stands for area, and specifically the area of a parallelogram or a rectangle. The area is solved by multiplying the base times the height. Right now, this formula or this literal equation is set up to solve for A, to solve for the area, because it says A equals. But we can take any equation and rewrite it so it's solving for a different variable. In the case of this, we might want to rewrite it to solve for B instead of presently solving for A. And the reason why that might make sense is because we already know what the area is. We already know what the height is, but we need to know, we need to use that information to solve for the base. So that would be really straightforward. I mean, we're just thinking of B as a variable that we need to solve for. So to solve for that, we simply would have to divide, since B is being multiplied by H, we'd have to divide the right side by H, the left side by H. The H's are going to cancel, and that's going to leave me with B isolated. That's what I'm aiming for. To solve for B, I want to isolate and solve for B in this case. Okay, so we've done that with one simple step, and rewriting this literal equation that was originally solved for area now says that the base is solved by taking the area and dividing by the height. So that's a real straightforward example. So I'm not going to go through the process of doing too many of these, but what I think we'll do is to scroll down. We'll scroll down. And why don't we do one more? This formula right here should look recognizable to us. It's the equation that solves for the area of a trapezoid. Now, if you didn't know that, then now you do, and you can go and fill that in on the front side. Okay, because I believe it was a formula back on the right-hand side. Oh, there it is. It's equation number 10. So that's area of a trapezoid. So let's get to work rewriting that so it solves for H. Right now it solves for the area. So solving for a different variable in this equation is no different than how we might solve for a variable in the equations that we just wrapped up doing. So we have to follow that simplify, isolate, solve process, and we just have to use reverse order of operations. So the first thing I'm going to need to focus on is undoing the fact that all of this, in parentheses, the B1 plus B2 times the H is all being divided by 2. So what we can start with is multiplying both sides by 2. That will allow the 2's to cross cancel, and that will leave me with 2A equals B1 plus B2 in parentheses times H. Okay, and I'll tell you what, I'm going to change the H to red since I know that's what we're going to solve for. So from here, this might get a little confusing for us, but just think about literally, in line with literal equations, think about this. 2 times the area is equal to the product of B1 plus B2 times H. So if I want to solve for H right now, I just have to undo the fact that H is being multiplied by all of this. And the way I can simply undo the fact that I'm multiplying H by all of that is to divide H by all of that. So I can wrap that in parentheses because that's the entire factor, so to speak, that we're dividing by. Those will cancel. And that's exactly what I'm looking to achieve here, is to getting to H equals. So we get H equals, remember, just like in an equation, we don't want to say something equals the variable that we're solving for. We want to say the variable equals whatever the result is. So H, isolated and solved for, is equal to 2A, 2 times the area, divided by the sum of B1 plus B2. Now, whether we keep that in parentheses or not is not all that critical. I will actually put it in parentheses, but without it, it does not change anything, because if we were solving for H, I would need to know the area and multiply it by 2. I would need to know the length of both my bases and add them together, and then divide my area doubled by the sum of these bases to work into solving for the height. Okay, so those are 2 of our literal equations that were solved for stated variables. Okay, so what I am going to ask is that you finish up solving the remaining formulas or the remaining equations for their stated variables. And we will review these in class when we next meet.